Guys, we're back to the OSHA report, the awesome OSHA report, because it gives us more data than anybody else so far. That's what's awesome about it. Of course, um, definitely a little biased now because I'm referencing the report. How awesome is that? Um, for clarity, a couple of times I speak in my videos about 8 feet when I'm referring to the canopy. The canopy is 16 feet. Also, for clarity, this report states that it was post-tensioning. Correction, there was grouting inside the duct work as reported by this report. And multiple times I've said that I have not seen that, um, the grouting inside there. So, I have, you guys can look yourself, trust but verify. Um, I'm biased now, so I find it hard since I'm in this report referenced in here, I'm biased in that I find it hard to attack the report at the same time. So there's my bias now. It's just something, psychologically that we're stuck with. But I'm sharing my bias with you. But you guys can go look and make your own decisions about whether you see grouting inside there um, or not. Or I try to find grout receipts from FIU. When I asked for grout receipts, I couldn't find it. I tried to find a grouting contract that it would have been paid. I could not find that. Perhaps they updated it. I did not see that update. I keep looking for updates on the reports, and I do not see that as updated. They could have slipped it in there, as far as I know. I don't go back and look at each one individually again. Randomly I do, but not the whole entire report each time. Moving on, the report this bridge collapse report states that we're going to talk about D1 through D6. And why is that important? D1 through D6. I think I did a couple of videos on this, but the latest one was in May where I talked to, I think it was Mark or something like that on here, and I talked about the issues. And I think that's when the other engineer also told me I don't understand behaviors of structures, and and I did a video on that also on that engineer attacking me, if you will. I call it attacks. Just psychologically, it's just attacks, right? So, but his point, he had no choice but to attack because he had a different conclusion. Nevertheless, I'm vindicated again because this report is going to stating what I stated in the video. Watch what we hear here. The center truss is rigid compared to the deck, and most of the forces will tend to remain in the truss members rather than to distribute in the 31-foot 8-inch wide deck and 9.5 inches as the minimum thickness. Okay, that's the minimum thickness. That's the edge of the deck. As the canopy. The deck. Remember, it's like a butterfly. I call it the wings, if you will. They go left and right from center line of the structure. And this report's referring to the curb area where you see the orange reflective material. Orange fall protection. That's not really fall protection, is it? 9.5 inches that curbing area. This also created shear lag in the deck, is what they're referring to as shear lag. The post-tension tendons in D1 through D6 are placed away from the junctions of the diagonal of the deck, and therefore no post-tension tendons at the center of the deck due to the location of the drain pipe, although the drain pipe could have been located elsewhere. You see this drain pipe conversation? I talked about this in this video here. Okay, I guess I have to. Okay, there it is. So I hit this again on May 27th. I talked about this. This report we're looking at is June. So clearly I'm ahead of the report on this one. And multiple times I went down this path of discussing this. But I'm going to just jump forward to 712 in the video. And this one is titled At This Time. And I do change the titles sometimes if I make a misspelling grammar mistake. FIU bridge collapse post-transverse cable failure. What's it called? Is there more details over here? Oh, cable failure, question mark. And let's just jump right at 712, and I think I did more of it ahead of time. But let's jump in, and I'm going to be discussing what the report stated, in June. I've discussed this in May. The base where they meet, the node area at the deck. Here's the longitudinal cables, and this would be D1, and D1 would be the same distance from center line over here approximately. They only show half the structure, and then you do it symmetrically. So, and let's bounce back over here. He's referring to D1 here. Therefore, the compressive forces imposed by tendons D1 through D6 in the deck are not effective in resisting the tensile forces in the immediate vicinity of the north end, D1 through D6. Let's go back to the video. You can see it doesn't land. I talked about this. It doesn't land on land. It's not over top of the longitudinal cables. The ducking was a big issue for me here, where they put the plumbing. Well, I said it's a big issue for me. And as you see here, D1 through D6 are placed away from the junction of the diagonal of the deck, and there are no post-tension tendons at the center of the deck due to the location of the drain pipe, which I refer to as a plumbing, although the drain pipe could have been located elsewhere. Therefore, the compressive forces imposed by the tendons D1 through D6 in the deck are not effective in resisting the tensile forces in the immediate vicinity of the north end, D1 through D6. And I talk about that, saying that these transverse cables are not strong enough to transfer the loads down through D1 through D6. Here we go. Where they had nothing underneath it directly. So for this load to transfer over to this D1 and the D1 over here also, it would have to do it span the distance with the concrete and any metal reinforcement they have. And you could then add, you then add the two transverse cables that are close to it, this one and this one. And you can see it basically surrounds it. In this case, it looks like it's in line with it pretty good, pretty much. But the distance here is great. It's 1 foot 10 center line, as we recall roughly. I think I said 1 foot 10, and they refer to as a minimum thickness. The post-tension D1 through D6 are placed away from the junction of the diagonal of the deck, and there are no post-tension tendons at the center of the deck due to the elongation of the pipe. And I talked about this in previous videos. There are nominal bundles of number 4 rebar. It's half-inch rebar, which are not capable of resisting such a large force. D1 is the nearest tendon to the center of the deck. D1 is. If an effective zone is created at D1 on both sides of the column 12, or in this example here, at an angle 45 degrees towards the south, it misses the junction of the center line diagonal number 11, with the top of the deck rendering it unable to resist any portion of the tensile forces. So he's following it all the way down through in this one. It's the entire length, but this one he's referring to is the straddles left and right of 11 and 12, which is also in line with all of these guys. Let's keep going. But I used this one. I took liberty, as I stated in this video. I'm taking liberty in the drawing. This is not the location of the failure. This is just me taking liberty, grabbing a section. And 1 foot 10 here. So you've got that 3 foot 8 inches. I think it's approximately from width to width. That this load would have to start transferring over to the first transverse cable before it can start transfer, and that's what he's referring to here. D1 is the nearest tendon to the center of the deck. If an effective zone is created, D1 on both sides of the column 12 at angle 45 degrees toward the south it misses the junction of the center line of diagonal 11, with the top of the deck rendering it unable to resist any portion of the tensile forces. So that's the same thing as I just took liberty there and not over here for clarity's sake for my video presentation. It's the same thing all the way down this deck, and we're looking at it here. He's stating it as the same. The opposite directions. Okay. And to do that, they use the transverse cables to do that. But these transverse cables are only capable of holding what? So 200 kips and 200 kips, 400 kips? They're a little more before failure. This is very questionable. They're not capable, I think, of transferring the loads without elongating these two here to make it over. Now that node on the underside, we don't have super details of it or the reinforcement, but we do have apparently a detail of how these transverse cables come under there. I'd like to look at this some more, but I can see where this would cause a deflection, cracking in the deck even around this area. So I point the arrows cracking around the deck area. this would also be down here, obviously, with the cracking we have. But I'm going to talk about the cracks here. And I hate to give it away ahead of time because I hate getting my thunder stolen by other people who give me thumbs down and then go to the other forums. But I'll give it away a little bit. Is that some of that cracking is a result during the failure, not presented, um, while the beforehand as photographic evidence. So some of that cracking and blowout is during the failure. It's not to be assumed to be happened beforehand while the bridge was still up in position. It was during failure those cracks, quite a few of those cracks. So that's the giveaway I'm giving for free now ahead of my video on this. I have other videos on this topic. In this case, we have a real video failure, and it's right about here. Which is oddly, it's like these two held up, and then forces didn't quite make it out to here. And that's what I talk about, the forces not making it out. And that's just what he states also in the report. Only if it made it out, and stayed on top of, only if it could stay on top of the longitudinal cables, we'd have all these forces, but but it couldn't stay on top of, as he's stating here. It could not make it. D1 is the nearest tendon to the center of the deck. If an effective zone is created at D1 on both sides of the column 12 at an angle of 45 degrees towards the south, it misses the junction of the center line of the diagonal 11. Okay, so there we go. Okay, let's read on. D2 through D6 are much farther apart to capture the tensile loads in an effective way at the end. This was inherent weakness in the design, and I talk about this with, I think, Mark. I'm guessing Mark's from England, where we talked about, and I said, look, it has to be able to transfer those loads equally through all these tendons, and I stated partially in this video about it just can't do it equally. It just can't do it with this, the zone of influence, I called it from Mark, zone of influence. And this is what they're referring to. I wish I could find those comments. Maybe Mark can find it. I think it was Mark. Or it might have been another guy there, but I thought it was Mark. The zone of influence. And if we could find those comments, you'll see the timeline stamped, if you will, on YouTube. And that's what this is referring to. So, yeah, that's where we're at. I'm going to stop this part of the video, and this was just more about the D1 through D6 and showing that mostly all of the content in this report I did a video on ahead of time. That, for example, this one here, D1 through D6, zone of influence, and I'm terminating video. You guys, as I stated a long time ago, you're betting on the right horse. And there we go. No offense intended to people who might be upset by this. Yep, we all can't be right. We all can't be right if we got opposite positions. And yeah, I'm the only one who took the opposite position of an entire forum on engine tips, which since blocked me from posting when I posted the one comment about come on, take this away from Trump. Somehow you attack Trump. I'm like, come on, or Republican Party. I was like, next thing I know, I got banned, and I only made like 3 total posts sharing my video content. All right, take care. Thanks for watching, and we're going to keep this up. I'm going to go over this entire report with you guys. I already have in multiple long videos already. Let's see if I can find it. I've got tons of, let's get rid of that. I've got tons of hours on this already since this report came out. I've got about 7 hours, but this is one, FIU collapse OSHA report. Okay, that was one we saw there. Another point I brought up, FIU bridge collapse OSHA report part 1. Bridge collapse truss load path system questioning tension failures is the failure. FIU bridge collapse, why no one determined. Okay, I already did that one. That means it needs to be the edit, but you can see that I've got these videos ready to go, but I'm not loading them until, well, I might go about a different format. Bye.